All right, so we want to do homework problem number 60 something out of chapter 12, which says, how many 3-person committees can I make out of 10 people? Okay, so over here, we have a little blob with 10 people in it, right? And you want to do what with those people?
Make 3-person committees.
Okay, so that sounds like there's kind of 3 slots, right? Okay, so my kind of initial response would maybe to be, I don't know, there's like 10 choices for the first spot, 9 choices for the next spot, and 8 choices for the third spot. But what?
But you've got a tail of people.
Yeah, I mean, there's some more people that aren't getting involved in this process, right? But what's the problem with saying it's 720?
Order.
Yeah, I've said in this process, right, that this chair and this chair are kind of different, right? You guys see that? Really, I've made way too many arrangements here because somehow this is different if I did Hope, Christian, and Megan, right? That's somehow different than the order that goes Christian, Hope, Megan. But that's still the same committee of people, right? So this is too big. Right, I overcounted. And I overcounted by the number of ways there are to take those 3 people and rearrange them. You guys see that? So we could do 10 things permuted into 3 slots and then divide by the number of ways there are to rearrange 3 slots. You guys see that? Right. You'd have to figure out how many rearrangements there are. That's not hard. Alternatively, what could we do? Like, what's a better idea? We already developed a theory for this. We may as well freaking use it.
Divide by the number of repeats.
There aren't any repeats, right? Because they're people. But I should divide by the number of rearrangements. But instead of thinking about how many rearrangements there are, just remember that instead of using permuted, you could use choose. So if I do 10 choose 3, what's the difference?
Divide by 3 factorial.
Yeah, so this guy, 10 choose 3, right, is 10 factorial divided by
7 factorial times 3 factorial.
Okay, good. So what was the 10 permuted 3 ways? What's that?
10 factorial divided by 7 factorial.
Perfect. Right? You guys see that? That's cutting the 7 tails off the end there. So that's my permutations. This is my permutations with the rearrangements cut out. So this is what I want. You want an honest number for that?
Sure.
Okay, so if we honest number that, I think we got 10 times 9 times 8 on the top, right? And I cut off the rest. And then I'm over what?
3 factorial?
3 factorial is 6. Yeah, so I think I can slash some stuff. So this is 10 times 3 times 4 is 120. Different ways to rearrange, or to pull, what? What was that pulling? What was it
3
doing?
people to make it.
Yeah.
To make a committee.
So there's 120 different possible committees, right? 3-person committees made out of this pool of 10 people. Useful? Questions, things?
Where did the 6 come from? I know we slashed the 7 and the 3.
Okay, so more precisely, this thing is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times times 2 times 1, right?
Yes.
And then on the bottom, you have a 7 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1. Take this stuff up here. That, oh, whoops, what did I forget?
The 3
Before I-
factorial.
I better put in my 3 factorial before I start onesiing things. Now, this stuff, the 7 factorial on top and bottom, right? That's a onesie. And then the 6 is 3 times 2. Cool? Questions, concerns?
And the 3 factorial is the how many arrangements of any chosen 3.
Yeah. So 3 factorial is the number of ways you can rearrange 3 things. You guys see that? So that's what I had here when I wrote over number of rearrangements and I didn't fill in what it was. The reason I didn't fill in what it was is we already have that in the choose notation, so you may as well do that. Right? Use the choose notation, don't develop it every